I'm Sasha. Today I'm going to tell you about web audio and MIDI APIs. Music has always been something that I understand and like, and I'm glad for that opportunity to touch this theme from the website. For this presentation, my self-designed task in dedication to each technology looks like that. The first is to describe what is it, what do we need to get started, the describe basic usage of each one, and growth directions. What do we need to do in mastering of these technologies? Okay, the first one is Web Audio API. It was developed to make developers be able to choose audio sources, shape them with different echo, different effects, even stereo ones, save record or put it to another destination, and so on. This technology is widely supported by almost all existing browsers, so it's good news that this powerful tool is so widely spread. Technically, we need just a browser to work with this, but it would really be useful to have EDI to create your code and some audio samples as sources. Excuse me. Theoretically, we need to know 4 crucial points, and it is the most essential thing to remember. So I ask you to pay attention to that. So everything that happens within audio API going on within audio context. So we need to create audio contexts. Within it, there should be a source and destination. Source could be loaded or created. Destination could be for record or to listening. And there should be connection between source and destination. In encoded form, it looks like that. The most basic usage, of course. We create audio context, then we create the source. In our example, it is oscillator node. We give it some type, sine 1, frequency value. After that, we connect oscillator with destination and make it play for specified time. There are 3 types of sources. It is oscillator, we used it previously, media file, microphone, and 2 types of destinations. This time I would like to invite you to hear about Web MIDI API. You'll understand further why. This technology was designed to connect Web MIDI devices with browser and to make able to understand Web MIDI messages. This technology is now widely supported with browsers. Okay, we need to live with this information. Our question, what do we need to get started, is we have it. So in this case, we need MIDI device, a special driver, special wire, and a browser, of course. Theoretically, we need to know how to receive and operate with MIDI messages. Plan for basic usage you could see on the screen, and the more essential thing in this is how to operate with MIDI message. To know this, we need to see 3 essential parts of MIDI message. It's command number, note velocity, and note number. Command number is shows us the event that happened to a digital keyboard. The first one is 144. If the command equals to that, this means that key was pressed. If the command number equals to 128, it means that key was released. Note number shows us how high on the keyboard the key is. Velocity shows how hard the key was pressed. The function to operate MIDI message looks like that. So we read the command value, compare it with 144, then read the note number, velocity, and if velocity is greater than 0, it means the key have some sound. We run note on function. If the sound is absent, we turn it off. And it's time to come back to Web Audio API, and we could test it. Let's start audio context. We know that it could be of different types. The first and default value is sine. I'll make it something louder. Square one is a little bit noisy. It's enough. Sawtooth, something like square one, and triangle. We'll start on this one. For now, we know that there is source, there is destination, and there is connection between them. But to add some effects, we need to know more. Effects are created with help of different notes. There are different types of notes, and I wasn't puzzled by describing all of them, but I would like to show you how to work with some ones. The first one is gain note. It is used to manipulate the volume of source before it's reached the destination. If we want to reshape the code, our previous code, to insert therein gain note, it would look like that. I would highlight the changes. On the fifth string, we create gain note and give it some value. After that, we need to connect our source, it means oscillator, with gain note. After that, gain note with context destination. And it's really essential thing that every note that is created should be connected with each other. Let's hear how it sounds. Small gain, almost we can hear it. Something in between, a little bit louder, and the most louder one. I think we need to stop on this one, or a little bit more louder. The next note is delay note. It creates a special delay between arrival of input data and its propagation to the output. And it is widely used to create echo effect. The scheme of this could be seen on the screen, and it is of course a little bit more complex than the usage of previous note, but it's not so dramatic. We could hear its effect without, with small echo, with high echo. Okay. Everything works. We'll step on small echo variant. And I think it's enough for today. It's everything I wanted to tell you, and it's time to sum up. Web MIDI API was developed to connect web MIDI devices to browsers and transmit MIDI messages. With help of information in which Web Audio API creates a sound, shape it with effects, could visualize it, and many more interesting things. Everything is happening within audio context. Of course, it's not everything, and we need a lot to do. My to-do list in this technology looks like that. You could broaden it with yourself, but I think it's a good point to start. On this part, we need to have some helpers. My helpers for this presentation was like that, and you also could use these links. And it's time to Sacramento. Thank you for watching. Thank you for your attention in presentation world. And let's listen to some music like that. I'll turn on the sound on my piano in order to have a more sweet sound, and make it something like that.